Okay, welcome to the HSC course for Standard Maths 2. The first unit we're going to be doing this year is trigonometry. Now, in order to find this in OneNote, obviously you guys are used to looking in here. Just to make it a little bit simpler, I've created another little topic here called Standard 2 HSC. So if you head to that topic first, and then underneath that will be the HSC topics, which of course at the moment there's just one. So we're going to lesson 1, which is right angle triangles. And right angle triangles, this is more revision of junior high school stuff, but there's basically two ways we can solve right angle triangle problems. We can use Pythagoras or we can use trigonometry. So Pythagoras is when we know two of the sides and we know there's a right angle involved. We can use the familiar a squared plus b squared equals c squared, and obviously we can change that around as is shown here. And then as well as that, we can use the basic sort of SOHCAHTOA stuff from trigonometry. So if we know one side and an angle, we can use trigonometry, or if we know two sides and we want to find the angle, find an angle, we can use that. So remembering that where we get SOHCAHTOA is sine is the opposite over the hypotenuse, cos is the adjacent over the hypotenuse, and tan is the opposite over the adjacent, and they're all nicely written there. So I'm just going to sort of squeeze through some of these examples as quick as I can. This stuff shouldn't be too difficult for us. So in this first question, we've been asked to find the length of an unknown side, and we have two other sides. So this is a Pythagoras question because there's no angles involved. If we're not being asked anything about angles in a right angle triangle, then we're not using Pythagoras. So either there should be an angle given. Sorry, we're not using trigonometry. For trigonometry, there has to either be an angle given or we have to be trying to find an angle. Otherwise, it's a Pythagoras question. So this is our good friends c squared equals a squared plus b squared. And in this particular case, we'll just substitute in. So we end up with 2 squared plus 5 squared. So we can, if you want to do that in your head, great. But I'll work on the assumption that most of you will probably use the calculator. So c squared equals 29, and don't forget the obvious step of finishing off by finding the square root to find out what c is. We don't want to know what c squared is, we want to know what c is. So in this case, that's 5.39. We'll go to 2 decimal places. If we're dealing with triangles, we're dealing with measurement, there's always units involved. Make sure you remember your units, and it's not a bad idea to tell whoever's watching that you rounded it to a certain amount. The second example there is just as simple, except this time we know the hypotenuse being the side opposite the right angle. So in this instance, we'd probably use a squared equals c squared minus b squared. Rearrange it that way, so we'll end up with 24 squared minus 15 squared. Please get into the habit of writing the formula, substituting in the formula, then do your calculation. So on this one, we've got 24 squared minus 15 squared, and that's going to give us a number, so that's 351. So that's what a squared is. We need to find the square root of that to find out what a is. So we just take the square root of and press the answer key to bring up the last answer, and that's going to be 18.73. Once again, that's units have to be written down, and not a bad idea to say that you intended to round it. Okay, moving along to the next one. So now we're in a situation where we've been given an angle and a side and we want to find another side. So different to the previous ones, an angle's involved, so we start thinking trigonometry. So if we think about this angle here, we use that as our reference point. This angle is opposite this side. It's adjacent. Adjacent is just another way of saying next door, so it's the next door neighbour of the angle, and obviously whatever's opposite the hypotenuse, opposite the right angle is always the hypotenuse. So in this particular side, we want to know this opposite, and we already know the hypotenuse. So these are the two sides we're concerned about. We're really not concerned at all here with the adjacent side. So for that, SOHCAHTOA, sine is the opposite over the hypotenuse. So sine theta equals the opposite over the hypotenuse. Once again, just get in the habit of writing that down. Now, whatever follows sine, cos, or tan is always an angle. So in this case, we know that that must be 31 degrees because that's the only angle there. Everything else in that particular question are distances. And so the opposite is x. We don't know what the opposite is. And the hypotenuse is 15. Now, if I was to multiply both sides by 15, I'm going to end up with 15 sine 31 degrees equals x. And then at that point, I plug that into my calculator and we'll get ourselves an answer. So 15, you don't have to use multiplied by here, but you can. You can just write 15 sine 31 degrees and that's fine. It's not a bad habit to get into to close the brackets afterwards. This question would have worked out if we didn't close the brackets, but some questions will cause a math error if you don't close the brackets after your sine, cos or tan ratio. So just best to be in the habit of doing it all the time. So we end up with 7.73, we'll call that. Our units are meters, so that's in meters, and that's the 2 decimal places. Moving across to the next one. This time, this is my reference angle. That's opposite. This is the hypotenuse because it's the side that doesn't touch the right angle. So once again, I've got sine again. So I'm going to have sine of 44 degrees equals, so the opposite, which is 12 over the hypotenuse, which is the x. Now, I'll just explain how this is done. If I was to multiply both sides by x, I would end up with x sine 44 degrees equals 12, because they would cancel each other out. And then if I divided, so I'll just do that in red so it's nice and, I'll do that in black, sorry, so it's clear to see which one's which. X sine 44 degrees equals 12. And then if I was to divide both sides by sine 44 degrees, then I would end up with x equals 12 over sine 44 degrees. Now, if you want to do it algebraically like that, great. That's a good practice to learn. But the other thing you can remember is when you've got the situation where the unknown's in the bottom, we can just sort of swap, and you'll see how once we get down to here, you can see what's happened. So we can do these intermediate steps, or you can just remember when the unknown is at the bottom, only when it's at the bottom, we can just swap the unknown with the trig ratio. So x has ended up out here, sine 44 has ended up as the denominator. That will always work as long as you use it in the right circumstance. So we put that into our calculator. So 12 over sine 44. And this time you'll have to close the brackets or it will cause an error. And we press equals, and so we ended up with 17.27 centimeters, and that's to 2 decimal places. Okay, so moving right along, there's another couple of ones here to do. I won't do these ones in completely, but I'll sort of get you started. So for this one, if we look at this angle, there's our opposite side, but it's kind of not involved. We don't care about the opposite side. We do care about the one next door, though. That's the adjacent. And obviously, opposite the right angle is going to be our hypotenuse. So in this particular question, we're concerned about the sides that are both adjacent and the hypotenuse. And for that, we're going to use cos. So cos theta equals the adjacent over the hypotenuse. So we can then just substitute in now 23 degrees, 15 minutes is our angle size. The adjacent, we don't know, that's P, and the hypotenuse is 16.4. So if we multiply both sides by 16.4, we're going to end up with 16.4 cos 23 degrees, 15 minutes is going to be equal to P. And so I will show this one fully because I just want to show you how to put that in the calculator if you can't remember from prelim. So 16.4 times by cos, and then we'll put 23, press the degrees minute second button, 15 degrees minute seconds button again. All right, make sure you press it twice, and that's going to give us our answer, which is 15, we'll go with 15.07 to 2 decimal places. Centimeters, that's the 2 decimal places. Okay, so for the next one, it's going to be somewhat similar, where we've got an adjacent side, we've got a hypotenuse, so we're going to be using cos, and it'll be in that form. Cos theta equals the adjacent over the hypotenuse. I'm going to leave that for you to do. I'd like you to have a go at that question yourself, and we'll move along. So these questions in the physical world don't deal with x's and that sort of stuff. They deal with unknown things. So here we've got an example of trying to find out the height of a flagpole. So we've walked 25 meters away from the flagpole, measured the angle up to the top of the flagpole as being 40 degrees. So we want to know how high the flagpole is. So with reference to this angle, the height is the opposite side, and this base is the adjacent side. And the one we don't care about is the hypotenuse. We assume, obviously, that the flagpole is at 90 degrees. So once again, we'll just use, if we've got the opposite and the adjacent, well, that's going to be tan. So tan theta equals the opposite over the adjacent. So we just substitute in what we know. We know the angle is 40 degrees. The opposite side is what we don't know, that's h, and the adjacent side is 25. We multiply both sides by 25. And we're going to end up with 25 tan 40 degrees equals h. We put that in our calculator. And we're going to end up with 20 point. Now it says to 1 decimal place, so this is 20. I'll just write 20.977. Not a bad idea when you have to round, to write a few more digits than you need, and then we can do the rounding. Now, in this particular case, it's actually going to round up to 21.0. Because it's to 1 decimal place, though, meters, we still need to put the 0.0 there to show that we have correctly rounded to 1 decimal place. Okay, so we've got the leaning tower of Pisa. I've got time for basically one more. I think I'll quickly talk about actually how to start both of these. So in the next example, we've got the Leaning Tower of Pisa, which is 55 metres tall, but it leans at 6 degrees. So how high is it above the actual ground? So we've got a hypotenuse here of 55 metres. We want to know this side here. Here's our angle. So the side next to the angle is the adjacent. This one up here is the opposite, but we don't really care much about this, and this is our hypotenuse. So if we care about the adjacent and the hypotenuse, we're looking at cos theta equals the adjacent over the hypotenuse. We just substitute in the values and away you go. All right. And then the final example here, we've got a wheelchair ramp, and they want to know how long is the ramp. So we're going to call this length of the ramp here, we're going to call that x. So obviously in relation to this angle, we've got the side next door, the adjacent side, and we've got the hypotenuse. So this is once again a cos question. So cos of the angle equals the adjacent over the hypotenuse, and we'll have to substitute in. So we're going to end up with cos of 18 degrees equals the adjacent, which is 8.7 over the hypotenuse, which we've called x. Now, if you remember, you can do the bit of algebra, or you can remember that in this situation where the unknown is at the bottom, we can just do a swap. And so we're going to end up with x equals 8.7 over cos 18 degrees. And I'll let you guys work out that. I'll actually probably put it in the Edpuzzle that I do for this lesson. So that's basically that. Most of this shouldn't be new to you. There's some good examples to try in the textbook. If you aren't comfortable with this, do as much of it as you can, because where we go to from here in trigonometry is a little bit more confusing. So you need to have this stuff battened down so that you can do the stuff that comes along later. It's not too complex, but you need to understand what this is first. And that'll do us for today.